Okay, so I'm going to start. The topic is artificial intelligence assist agricultural production. This is what we're going to learn in our first module. We're going to define what AI is. Dr. Jim already talked about it, and also watch the video. Talk about machine learning, deep learning. And then for that, we're going to do the overview of AI types. We're going to talk about supervised, unsupervised, deep learning, and reinforcement learning. These are the very commonly used. And then I'll talk about agricultural data science pipeline. How do you uh, work with data from acquisition to decision making? Then briefly we'll talk about application of AI. That will continue with that tomorrow. If we don't finish, we'll pick up where we left from today. Okay, so this is what we've been doing. So what's AI? Dr. Jim already taken us through, but I'm going to emphasize a little bit here. So it is a science for creating systems that can perform tasks that normally require human intelligence. So when the doctor introduced artificial AI, he compared it with human brain. So it's a science for creating systems that can perform tasks that normally require human intelligence. Example, precision irrigation system. So if you have that system, AI models analyze soil moisture, so weather forecast and crop type. And then it can also, sensors in the field can send real-time data to the algorithm, and the system automatically adjusts irrigation. So if you have a irrigation system, AI will measure soil moisture, the weather forecast, whether it's going to rain or not, because it's already been predicted. And then when maybe the irrigation was taking place, it's going to adjust irrigation automatically, and that will save water. So also improving yield, because if you have too much water, you get some problems with the crop. And then also reducing the cost. So it's used in smart farming to optimize resources and increase sustainability. So what's the goal? Is to enable machine to learn, reason, and act intelligently. So that's what AI is basically, doing something that this human being can perform. And we'll see that sometimes when now you reach the generative AI, we're going to see in the next few slides, it does not only use historical data, it uses the historical data, and then it now can create something else. Okay. So AI engineering in general, we can also, because this way we're talking in agriculture, but we can also apply AI in engineering. So you can work with machine, which is fitted on Internet of Things sensors. You can work on vibration, temperature, and sound. So what we are discussing here can also be applied in other fields of engineering. So, for example, you can analyze data to predict equipment failures before they occur. So if you have information, historical data, your 20-year models, then those models can predict equipment failures before they occur. So that will help engineers to set timely maintenance, reducing downtime and cost. So in the process, you're improving safety, you're improving efficiency, and improving lifespan of the equipment. So this week we'll been talking about AI in related to agriculture engineering and crop. But AI can be applied to any engineering field. Okay, I just wanted to put this here. So what's his Internet of Things? People always talk about Internet of Things. So it's just written in capital I, small letter O, and capital T. So basically, this is a network of physical devices. So they're called things, and they're connected to the internet. So they're capable of collecting, sending, and receiving data. For example, one time I was in San Francisco. So when I went to my room, before I went to my room, I booked online. So they sent me a code. So when I reached, I went and used the code to open my hotel room. Then when I entered, the fridge, the TV, everything was connected. So if I wanted to take beer, I just open the fridge, take one bottle, and then after a few seconds, the receipts come on my phone. So that's what's called Internet of Things. Things are connected, and they're able to, that fridge was able to collect information that I've taken one beer from there. And that information was sent to a cashier, and the cashier sent me the receipts, and I had to pay using my credit card on my phone. So that's what I mean by Internet of Things. And what are devices that are included? You have sensors, you have machines, you have vehicles, appliances, and wearables. Even these days, sometimes you have watches that you can wear and can send information to your doctor about your health, how your heart rate is going, and so forth. And they're called smart devices because they can also communicate with each other with a central system. It's a little bit scary, but that's what Internet of Things does. Because the goal is to be able to automate, monitor, and decision making without constant human input. Okay, so it also has some disadvantages, but of course, people lose their jobs, but still, it makes life a little bit easier. Okay. Okay. So this training, the title was AI. So I started by defining what an AI is, but in the course of the training, you'll see how connected AI is a subset of data science, and also see how connected AI with other field of data science and analytics. So I wanted to at least bring the connection of AI and data science. So what's data science anyway? Data science is about extracting knowledge and insights from structured and unstructured data. So what is structured data? Structured data are the data that we are used with. They're many in tables. So you go to the field, you collect your data. On the left column, you have maybe the list of names or parameters, and then on the horizontal, the columns now you can take your let's talk about crop. You can take height. You can take other things. So those are what we call structured data, and that's the type of data we are used to. What about unstructured data? Unstructured data are the data that are just unstructured. For example, the WhatsApp message, the text that you write, all those, including messages, those are unstructured data. So what data science does, extract knowledge from both the structured and unstructured data. And AI relies on data science pipeline. Okay, so it's a subset of data science basically. So it relies on data collection, cleaning, analysis to learn pattern. So data fuels AI. Without data, you won't have AI. And that data has to be very high quality. So AI cannot make accurate predictions or decisions if your data set is biased. For example, sometimes people do training in with law enforcement. So we've been getting that problem in the US. So people who develop software for identifying criminals, but 80% of the training sets are Caucasian, white, maybe 20% are black. So that's not a very good representative. So when you train algorithm like that, and you use it, sometimes becomes biased. So you have to have high quality data. That means the data should not be biased. If you're going to train your algorithm or your AI method, you have to make sure that there's a representation, okay? Because with AI, what it takes in is what it gives out. So if you're not going to have a very good high quality data, then your models will not do good jobs. Okay. So that's the relationship between AI and data science. Okay. What about AI and machine learning? So machine learning is just a subset of AI. Okay. So you have data science, and then about data science, you have AI comes, then machine learning. Those are algorithms that AI uses. So machine learning uses algorithm to learn from data and improve time without explicit programming. So with machine learning, you have to, it learns. It learns without being, when you give it the data, it learns without explicit programming. What do I mean by that? Because that goes back to hypothesis. It used to be you plan your experiment, you collect data, you have this hypothesis that you already have, and then you do the experiment, you analyze. When you're using machine learning or AI, sometimes you don't even know what the hypothesis is. You collect that data, and then from the analysis, then the hypothesis came in. Then now you can go back to the traditional one. Okay? So the example, we use the machine learning as spam filters, recommendation systems, crop yield prediction. So in short, AI is the big version of machine learning. The practical engine that makes it work is machine learning. Okay? Another part that I wanted to talk about is AI and analytics. So what's analytics? Analytics interpreting data to guide business or scientific decisions. We are scientists or engineers, we're in the same group. So analytics interprets data and guide us, whether in the business world, engineering world, or science world, to make decisions. And there are 4 types of analytics. There's descriptive analytics, there's diagnostic analytics, predictive, and prescriptive analytics. So all of those 4, they support AI applications. Without those, AI cannot work alone without analytics, because analytics, those 4 areas, have to support the AI. So basically, AI enhances analytics by automating the process, detecting hidden patterns, and generating new insight at scale. So they work hand in hand. So we saw how AI is related to data science. We saw AI is related to machine learning. Now we can see where AI is related to analytics. Okay. So basically, if you go back, analytics is the core of data science. So AI helps by automating the process. Okay. Okay. So I talked about AI. That's why I wanted first to introduce AI. For introducing AI, relate AI to data science, relate the AI to machine learning, relate the AI to analytics. But what we're going to study the next 4 days is data. What basically is data science, really. So what's data science? Data science is data-driven. It is an interdisciplinary field focuses on extracting knowledge and insights from data. And at its core is analytics. So the analytics is the ones that drive data science, is also the ones that drives AI. So analytics has the power. It has powers this process by transforming raw data into actual insights. So as I already mentioned, we have 4 types of descriptive analytics, of diagnostic analytics, predictive analytics, prescriptive analytics, and now we have generative artificial intelligence, what they call Gen AI. So I'm going to spend some time go through this. If we can understand this, then using AI will be very, very easy. This is the core data science, by the way, this 4. analytics. And now we have Gen AI added to that. Okay. So to achieve what data science to achieve, it has to draw all from multiple disciplines, including statistics. So statistics will help you understand the data pattern and distribution. Computer science is to manage, process, and scale the data workflows. So mathematics is to model relationships and optimize outcome. You see AI come in now. It came in here under data science. It is in machine learning automate, insight generation, and prediction. And last but not least, that people always miss out is domain experts. You cannot do AI, you cannot do data science, you cannot do machine learning without working with a domain expert. I'm going to give you 4 examples of. I'm a data scientist and bioinformaticist, but I work with. I've worked in human resource. I've worked in health. I've worked in agriculture. I've worked in other fields. So I'm going to give you 4 examples where I've worked, but what helped with domain expert. The first one was in 2019. We got a contract with the Uganda Revenue Authority. So we worked with them. They gave us access to their data. But we reached a stage where we needed now, because by then we didn't know anything about taxes at all. So after doing the analysis, we had to go back and sit with people who were in custom, people with exercise, and all this. So you have to work with them. So we worked with them for 9 months. And then, of course, we gave them the report. So the changes that started happening from like 2020 onward was because of our work, that we work with their data. But we needed domain experts from URA. Another work that we did was with Brazil. So what they did, there was a very high rate of attrition. People were leaving. So they hired us to find out why people were leaving. So what we did, they had the data. We collected data from exit interview, because when you leave, you give exit interview. We collected data from people who have been there, and also from management. So after analysis, we came with different clusters, and that's where we stopped. So we had to go back and sit with the managers, the people who were on the floor. They were very, very important in helping. And then we had even to call people who left. So in the end, we found that we were divided. There were 4 divisions. So then we had now to recommend based on that division. The third example is agriculture. Agriculture, we're working with a company in Kenya that were using drones. So again, after doing all the analysis, we had to go back to the farm manager, extension agent, and then even the farmers themselves. And last but not least, we work with insurance company. There are people who are getting into insurance, and then after 1 year, they drop out. So we work with the data. We discovered something, but we had to sit with the adjuster, all this. So what we found that, because they want to increase the number of agents, but that was the problem, because the agents they had, what they what they were doing, because that system was, if somebody stays for 1 year, you get 40% of that of that premium. So what they could do, they just go anywhere and recruit anybody. And then in the process, after 1 year, they get their bonuses. These guys leave. So if we didn't work with the domain expert, people who are in insurance, we would not do that. So if the take-home message from this training is, any data scientist or analyst who want to work, you cannot work alone. You have to work with a domain expert in that field, because data science is basically kind of like a tool or AI to help make decisions, to help do things, but you have to have the domain expert. So I had to spend some time here, because this is what always people do. people don't pay attention. You need to work with the domain expert in that field. Okay. So what are the requirements of data science? You have to have a strong foundation of qualitative skills. Engineers already have that. Statistics, mathematics, econometric, biometry, proficiency in tools and programming language. We're going to use R and R Studio here. I don't know how much already installed, but we're going to use R and R Studio. Why? Because it's an open source. There's a steep learning curve, but if you practice, it's going to help. We're going to use that. So you also have to have ability to work with domain expert. Example, if I'm working with an engineers have to help me. If I work with HR, they have to help me. And then you have to have the problem solving, analytic thinking. And then last but not least, you have to know how to manipulate data not in a bad way, how to visualize it, and how to do modeling skill. It's not scary, but you have to have at least the basic of some of these skills to do data science and AI. Because AI, what I'm talking about, AI is a component of data science. That's why I tried to bring data science on top, AI and machine learning. So the tools we're going to use for this training is R&R Studio and QGIS. I sent a link, I sent a document, a file to Engineer Jimmy to share with you guys. If you haven't installed it yet, we're going to, on Thursday, we're going to do practical. So I would really encourage you to try and install this package. They're free because what I would like to do is even after this training, you can be able to use these tools here because they're very, very powerful. We have tools out there, but you have to buy them. So I always, when I'm working, especially in developing countries, I try to bring these tools that are free so that we can work with. Okay. Okay. So that was an introduction of AI, and then I brought in data science. I brought in analytics. I tied them together. Then I went back to data science as the core. And then I also discussed what's needed. And I talked about domain experts, the most important. But under all this, you need analytics. Because the process of data science is basically analytics, those four areas of analytics. When I'm doing, I'll be interchanging data science and AI. When you're doing your AI or data science, you're doing basic analytics, okay? So I'm gonna spend some time and discuss what analytics is, okay? So what's analytics? So analytics allows us to derive value from data by answering four key questions. Because when you're using AI, without data, there's no AI. Without data, there's no data science. So analytics allows us to derive value from data by answering four key questions. What happened? Why did it happen? What's happening now, or what might happen, and what might happen in the future? So in other words, analytics is a process by which you take your raw data, that's AI, convert it into relevant insights that can inform organization, improve performance, and guide strategy. So if you're using AI, you're going to get data, or drone data, or sensors data, or going to collect the field. But at the end, you're going to ask these four questions. What happened? Why did it happen? What's happening now, or what might happen? What might happen in the future? Okay. So we're going to spend some time covering one by one, and what are the tools that are required for those. Okay. So what's the benefit of analytics? So basically, it gets your raw data and works with it, and you get your insights. So it helps organization to optimize resources. It helps organization to reduce inefficiencies. It helps organization to improve performance, and then to also forecast future outcomes. So it's the benefit of it. So we're going to start with the first one, descriptive analytics. The descriptive analytics answer that question, what happened? It's the first, when you're doing any analysis, it's the first part of AI process. So what it does, it focuses on summarizing the past data to explain what has occurred over time. That's why it's what happened. So in agriculture, for example, this may include analyzing crop yield trend, soil nutrient average, rainfall records, pest outbreak across multiple seasons. So for example, we have locusts, I think came a few years ago. So the first thing that you ask, what happened? The locusts came. That was the first question. That's descriptive analytics. So maybe if you go back to historical data, you can look through how often does the locust swarm come to Uganda. So that will answer that question, what happened? What about crop yield? So you go into somebody's farm, look at their records maybe for the last 10 or 15 years. They have the average. So that's the question, what happened? You can take soil nutrients, you go and use their probe, and then you find that this soil has a certain amount of nitrogen, phosphorus, and potassium, and so forth. So basically, that's descriptive analytics. What happened? So with that, you can such summary enable a farmer, an engineer, a policymaker recognize a pattern, evaluate system perform, and make informed improvement in the farming practice if you're a farmer. So the last 2 years, the year was doing well, and then this year you didn't get a good crop. So that would be the question, what happened? That's the descriptive analytics, okay? And there are methods of of working with descriptive analytics. For example, this is a crop recommendation data. We have 8 different types of crops on the left. And then here you have nitrogen, phosphorus, potassium, temperature, and average humidity, and so forth. And then second last, you have the yield for each crop. And then the category high or low. So if you get data like this structured data, the first thing you look at it, you have 8 different types of crops. They need different types of nitrogen, phosphorus, and so forth. And then, of course, you look at the yield per kilogram per hectare, and the categories, some were high and some were low. So the first question is, let's take maize. What happened? Why were they lying on 75 N, 32.3 P, and 1.6 K, and so forth? And why is the pH? So this is the question that you descriptive analytics. What happened in the beginning? What happened? Okay. Then we'll take you to descriptive analytics, ask question, what happened? And then we come to diagnostic analytics. Why did it happen? Why the last 2 years we were getting good yield? What happened this year? That's diagnostic analytics. 6 why something happened? You have your descriptive, the locust came. And then now you ask yourself, okay, if the locusts keep coming every maybe 10, 15 years, now you go and ask, why do they come? There should be something. Okay. So in agriculture, this might involve examining soil test results. If you let's, I'm going to stick I'm going to stick now with the crop. So he's a farmer. The last 2 years, his maize yield were really good, high. And then the average this year was very low. So the descriptive analytics discovered that the yield was low. That was what happened. So now diagnostic analytics will ask, why did it happen? So how do you find out? You can go and do soil test, and then, okay, you can go and see your record of how you're applying irrigation. Was there pest infestation? You can also go and look at your what? Your fertilizer application records. So that's diagnostic analytics. Why did the maize yield came down last year? So now by uncovering those causal factors, an engineer, but maybe he's working an engineer, can now pinpoint problems to recommend corrective measures. For example, let's take uh, irrigation practices. So the engineer knows a lot about the irrigation machine. So maybe after doing the soil test, results were no problem. We didn't have any pest, and the application fertilizer was good. Then now we go to irrigation practices. Was there a problem with the irrigation machine? So this now agricultural engineers will come in to find out what the problem was. But we started with descriptive analytics. What happened? The yield was low. Why did that happen? You go through all these scenarios to eliminate the problem. So by uncovering causal factors, the engineer can pinpoint problems, recommend corrective measure. Okay? So that's where the engineer would come in here. So example, identify cause of yield crops, detect relationship between soil and crop health, report fertilizer pesticide application. So that is one step after predictive descriptive analytics, okay? So this is how you can also diagnose. I told you we also have tools for doing that. You can do correlation. You can plot. So the yield, you can see if this the blue means they're positive correlated, and pinkish means they're negative correlated. Okay, you can do the correlation. Just use the table that I showed before. So you can see, okay, yield is positive correlated with nitrogen and so forth, and you can see the pH and so forth. So when you plot some of this, it will help you. Okay. Okay. So we talked about descriptive analytics, what happened, diagnostic analytics, why did it happen? Now we're going to go to predictive analytics, what might happen. So when people talk about analytics, they don't talk about the first two and the last one. If talk about AI, they just go straight to predictive analytics. But to do a good job, you have to know to go through all those type of analytics. So this uses historical data in real time. Always combine your AI and machine learning models to forecast what's likely to happen in the future. So in agriculture, this could mean predicting future crop yield, pest outbreak, soil moisture level, machine outbreaks. Okay, so we know maybe I'm going to go back to pest now to locust. So there are factors that make these locusts come to a country. It's not maybe one or two. But now you have this historical data, locust has been coming. You can go back and now start looking at sometime maybe the rainfall information and other futures for different crops. Then now you can use that to predict when are these locusts coming again. When it's going to be an outbreak. Crop yield. The last few years you were doing well, and then this year something happened. So that's your record. You don't have to wait for it to happen again. So the historical data now you build your AI model. So maybe at every beginning of the season, you use the algorithm to see what might happen. So that will help you prepare in advance. So for engineers and farmers, they prepare them so that they can reduce their risk. So that's what predictive analytics does. Okay. It helps. It helps with predicting the future. Okay. So descriptive asks what happened, diagnostic, why did it happen, predicted what might happen. Okay. So now let's go back. So let's go back to this table here. So this table we're given, we did some analysis. We did descriptive analytics mainly is you do the mean, median, and so forth. So we did that. And something like that. And then when you go to diagnostic analytics, you can use the correlation, you can use t-test and the rest. And then now we can now go and do a predictive analytics. So we have all this information. You have information about maize, about the crop, about the nitrogen, phosphorus, and so forth, the temperature, and so forth. So you build a model, you build your models. So this is for predicting whether it's going to be high or low yield. So you have all this model, all this information. You can now use your predictive analytics. You don't have to wait. So now when you have that model. So in the future, you use your AI or machine learning. So if you have this information here now, the new data, you can now use the model that you use the model that you got from the historical data, predict how their yield is going to be. Okay. And of course, any prediction is not 100% accurate. But what you have to do, make sure that your accuracy is high. So for example, let's call this as a test data. So we use historical data, we build our model, and then from that historical data, you divide them into two. That's how AI people do. You train and you test. So assume this was the test data set. So the reference is the ones that were really from the data. So you can see from here, most of them were predicted correctly, but if you look at the yellow, this was supposed to be high, was predicted low, and so forth. So there's something that they call confusion matrix that help you to determine whether your model is good or not. Okay. Okay. So I've talked about three types of analytics. Descriptive analytics asks you the question, what happened? Diagnostic, why did it happen? Predicted, what might happen now? And the last but not least is predictive analytics. So if you develop your model, somebody has to use it somewhere, either a farmer or an engineer. So this one is called prescriptive analytics. It goes beyond prediction, suggest the best course of action. So in agriculture, this could involve AI-driven tools that recommend optimal planting times, irrigation scheduling, fertilizer amount or pest amount based on multiple data input. Okay, so that is basically the last part before generative AI came. I'm going to talk about generative AI later. But after going through all those four, that's the process. Then now you have to make sure that somebody uses your model, basically. Somebody either going to put it in a machine or in an app after going through all that. So that is now where to use the model will be to maximize your yield, optimize resource use, and improve sustainability in farming system. So this is the last part of analytics. So in summary, this analytics in agriculture engineering, your descriptive analytics asks you a question, what happened? For example, crop yield, soil, rainfall, and I talked about low yield. And then you ask, why did it happen? Identify causes of low yield and poor soil and so forth. What's likely to happen? Forecast the yield. And then what should we do? That's predictive analytics. Recommend best planting times, fertilizer schedule, and irrigation plans. So all this is AI, basically. AI, if you do AI, you have to go through these processes here. Okay. I'm sure all of us, we have used ChatGPT. So ChatGPT is the latest part of analytics, basically. It's called generative AI. What should be done? So this is an emerging form of AI that can create new content such as text, images, audio, code, and simulation. The difference between generative AI and all the analysts I've talked about is, for example, we had low yield, we got historical data, we did the prediction. In the future, it's going to be the high yield or low yield. And with Gen AI, you can train Gen AI, but it will create something totally new. Something totally new. So it's a little bit scary, but that's where we are going. So it's unlike traditional AI, which means analyze existing data. This one generates something new, make it work for creativity, prediction, and problem solving in agriculture. It's scary, but it's also help. So that is what Gen AI is doing. I mean, if you use ChatGPT, basically you're using generative AI. So it complements conventional analytics by broadening opportunities for model training. So it's good in simulating and explore future farming scenario. So sometimes we don't even have data, but Gen AI can generate for you data that's almost similar to what you have. So generative AI is an emerging area that it has, yeah, it's expensive because of the training, but people are using it a lot.
Doctor, you are not audible enough,
Can you hear me? Can you hear
but
me
you are
better?
very volume is low.
Can you hear me now better? Hello?
Yes, a little bit better now.
Okay, sorry about that. I wish you told me earlier. Sorry about that. So yeah, so I was talking about generative AI. So it's an emerging field. So I think we all use almost GPT every day. Is basically generative AI. Because you can train it and create something totally different. You can train it with a text. That text you can get image, you can get audio, you can even code, you can do simulation. Okay. So how can we apply Gen AI in agriculture? It can generate synthetic images of disease plants, can help train AI models to detect crops stress disease earlier, even if we have limited data. So people are now using that. Irrigation scenario, it can simulate different rainfall, soil, and crop conditions. Engineer can test what if irrigation schedule before implementing, saving water and cost. Farming equipment optimization can create virtual prototype of farm machinery components. Engineers can test digitally, reducing time spent produce product development. Climate impact forecasting. It's generating multiple climate change scenarios. So this can help also engineers and policymakers plan resilient farming strategy. So something that people started using it, but the problem is very, very expensive to train the models. It's very, very expensive. So that is the disadvantage of it, because like in the US, you have all these areas where we have these data centers that take a lot of electricity, but they're working. Okay, so that was about the analytics methods. Okay, so AI depends on the different method of analytics. Uh, so that so next we are going to talk about AI or machine learning methods. Okay.
Maybe before you proceed,
Sure.
could actually allow some questions, but I also want to say something about this generative AI, where
Yes.
you can actually create new knowledge. Colleagues, that's where our ethics come in, because this new knowledge you're trying to create from generative AI has to be ethical enough. Yeah, you've had issues whereby people create completely, okay, they're able to feed into AI different types of music and produce another completely another kind of music from even singers who died, for instance. So
Exactly.
we have to be careful as engineers when we're using generative AI that it does not violate ethical norms. It's very also applicable in security, for instance. I should be able to, I can describe somebody when I've not even, don't have their image. and then it should be able to generate images related to my description. But we need to think at the back of our minds as professionals that it can also cross the line of ethical issues. That's what I wanted to bring out now. But if we could allow maybe a question or two from the audience,
Sure.
so that we're sure,
I'll be happy to do that. Sure, go ahead.
so that we were sure that people are following and not just logging in and only listening. Thank you.
Okay. So what about my speed? Because sometimes I have this accent and people don't get me very well. Is the speed okay?
From my side, it should be fine. It's fine. But they will tell us, our participants, our customers will tell us how we are performing. So
Yeah.
colleagues, you can unmute and give us some feedback if the speed is okay or you have any question. Someone saying the speed is too fast. But do you have any question from what has been discussed so far? The participants on chat.
What I can do?
Hello,
There is
Doctor.
one. Yes, please go ahead.
I'm Joshua Nyeto. I wanted to find out, maybe I missed it a bit. Is there a difference between AI and machine learning?
Yeah, machine learning is a subset of AI. AI use machine learning algorithm to perform the work. So there are very many algorithms for machine learning. So basically, machine learning is a subset of AI. So you have data sciences on top, then comes AI, and then machine learning is a subset of AI, really. Sometimes people use them interchangeably. But machine learning is basically the algorithm.
Yeah, okay. So machine learning is one of the algorithms of AI,
Exactly.
right?
Yeah.
Okay.
I
Because
think
AI, you can also use statistics, you can use mathematics, you can use, yeah. Go ahead.
yeah, but most importantly, colleagues, AI cannot override our human intelligence, and AI will rely on what we input. So
Exactly.
if you have enough data, then you're giving it an ability to learn more about you. It's like if I tell you, talk about yourself. So the more you explain who you are, the more I understand who it is. But if you also gloss over who you are, it's difficult. So that's the same way the machine that you're trying to pick this knowledge here. So even if we use it to predict data, the historical data is very, very important. That measured data, the one you've measured, is very important. If you have time series, for instance, you have to make sure that the what is predicted has to be able, you're able to fit it in on what on the historical data. You don't want to have something that is really out of range because you're not trying to create something out of the ordinary. That's what I wanted to say. But I think you can proceed, Doctor.
Okay. So I'll try to go a little bit slow and also be audible, okay? So these are some of the machine learning methods that are very commonly used. The first one is supervised learning. So this is a type of machine learning where models are trained on labeled data. So I'll show you the cartoon later. So they're called supervised because they're trained on labeled data. So the inputs are always paired with the correct output. So let me go back here. This is supervised learning because we're training this model and giving the model that this maze here, after by applying 75 kilogram of nitrogen, 2.3 kilogram phosphorus, and 130 kilogram of potassium at this temperature, humidity and pH rainfall, the yield was high. Okay, so we are supervising our model because we are giving the output. So this model will learn how to predict whether it is high or low given a crop and information about the soil fertility, temperature, humidity, pH, and so forth. So this is what's called supervised learning. Go back and okay, so what machine does learn to map inputs to outputs by minimizing error during the training. Because the inputs, if you look at the graph I showed you, the input was the ones that were shaded yellow with red font, and the output was high and low. So there are two types of supervised learning. The first one is called classification. So these just predict categories. So the graph that I showed you, that was classification. It was predicting whether the yield is going to be high or low. But if we were estimating the real yield, that would have been a regression problem. So let me go back and show the difference between the two. So the classification problem classifies this category, okay? It is a high yield or low yield. But let me go back to the original data. See this original data? Original data had yield kilogram per hectare and also yield category. So we can model, we can supervise machine learning can do two things here. These are independent variable, all this. We can also build machine learning that can predict for us the yield in kilogram. And that the process is called regression method because we are predicting numbers. But if you're predicting a category like high or low, it's a classification problem. So when you're doing machine learning supervised method, you can either do classification or regression. Okay, let me go back here. So we have classification, predicting categories. Example, crop yield is disease versus healthy. Our yield was high or low. But the regression problem, you're predicting what? The real numbers. So the goal is generate from your training data to make accurate prediction of new or unseen data. So this is widely used, of course, in agriculture, health, speech recognition, and computer vision. That's supervised learning. It's like a cartoon here to show you. So supervised learning, you have your label data here, and you want to see the yield. And this is your model. After the model, it's going to be, you can predict either high yield or low yield. This is supervised because it's learning being labeled. So how do you do it? The left section, I'm explaining this infographic, this cartoon here. This is the left, this is middle, this is right. Okay, just follow me. Left, label data. In the middle, your model. On the right, your prediction. So that's what I'm saying, I'm explaining here. So show agricultural input. So that label can be your agricultural input, can be a soil, rainfall, sunshine, and crop growth. So that's what you use for the trade. And then now each point in the input paired with the label. For example, we had high yield or low yield. And this represents what's called training data. So your left is your training data. Okay. So the system is giving an example of conditions along with the correct outcome. So this, from here, we have our training data, we are labeling it, okay? So we have high yield, low yield, and so forth. Now the middle section, this is the middle section here, the model. It's the middle section, the model. So this depicts a decision tree or an attractor icon is the learning mechanism. So I put here as a learning mechanism to be a tractor. So this model learns now what was here labeled. So the model will learn. Okay. The model is learning now. So that in the future, can predict whether it's a high yield or it's a low yield. So that was the model. So the model is trained to recognize patterns in the label data. It learns the relationship between the inputs, which is on the left, your soil information, your weather, your nutrients, related to your output, which is the yield level. So that's what the model is doing. That's what's called modeling. Okay, that was the modeling part. So in AI, when you're doing work with AI, this part doesn't take long. The part that takes long is data preparation. On the left, that one takes maybe like 60 or 70% of your time. This one is the engine, but if you have a very good data set, you have a representative, this will not take long, okay? And then the right is your prediction section. So it shows maize crop and outcome level with high yield or low yield. So it presents how the trained model applies knowledge to new and seen data set. So for example, given this season rainfall and soil data, the model is going to predict for you whether you're going to have the harvest is going to be high or low. Because use the historical data, now you're collecting soil, the information on rainfall to this season. You already have your agronomist or extension agent has collected information on soil. So before even you do the harvesting, you should plug in this information in the model. It's going to tell you if you're going to have either high yield or low yield. And that is this part here, the last part. Okay, so the model that you've trained here, and now you have your external agent got those information for soil, you have a rain gauge somewhere, you just punch it, will tell you whether it's going to be high yield or low yield for that year. And that also will give you time to do what? To plan. In case you have insurance on the for your crop, especially for commercial farmers, then you can start now talking with the adjuster what's going to happen. Okay? Since I've explained this. So what's the key applications in agriculture? We have yield prediction. It estimates harvest outcomes based on weather and soil condition. Another area that we can use is crop disease classification. You can identify disease versus healthy plant from images. Soil fertility mapping can predict soil nutrients to guide you in fertilizer use. Okay? So Dr. Jimmy, how many minutes should I give you for Q&A? We have 11 minutes left.
I think proceed. We lost already some time. So I think you'll proceed at 6. We shall give them to some Q&A at 6 o'clock.
Okay. The next method that's using machine learning is called unsupervised learning. So this is a type of machine learning where your models find patterns in unlabeled data. You don't feed anything, you just give your data, the information, and the system group the groups or cluster or reduces all these by themselves. Okay? So the goal here, you don't know anything about your data. So the goal here is to discover hidden structures, similarities, or anomalies in data sets. So it's always used when labeled data is scarce. It's common use in African agriculture. So what's the application? Clustering farm by soil fertility. You can get information from all these farms. You go get maybe your neighbors in the village. You get their soil, and then the type that you just push in and supervised learning, and then you find these villages are clustered based on what? On the soil. Also, you can group crops by growth stage or disease type. Market segmentation of farmers. You can do that for advanced wealth services. You can also detect anomalies, e.g. unusual rainfall or pest outbreak. So this one, you don't label your data. This is a very, very powerful tool, a machine learning tool. The methods like principal component analysis, cluster analysis are the ones that are unsupervised learning. Okay? So this is an example. So you have your input data, you have yield, no training at all. You just put them in the model, and then they're clustered, the output. So you find the healthy maize is here, the stress method here, and the disease maize is here. But nothing was trained. You just put your input in. Okay, let me explain this, what I just showed you. On the left, you have different unlabeled agriculture data such as rainfall, soil conditions, crop growth observation, and yield records. You just have this for all these fields, including your neighbor's fields. All this, you collect that. And then after that, you just put in the model. And then from the model will just give you the output, clustered a certain group in a certain area. And then if you go detail, you look at example like principal component, there's what is called eigenvalues, will tell you which of these are contributing to the grouping. Okay? And then the model part is the middle. So you see we show as clustering scatter of dots forming natural groups. So this one here. So you fed this here, and then now starting to have this group is coming together. This group is coming together, and this group is coming together. So this group might be the healthy maize. This group might be the stress maize, and this group might be the disease maize. Okay. Okay, so the tractor represents AI in generalizing and grouping the data, and the algorithm finds pattern without being told the right answer. So in a layman's language, that's the middle part. It finds the pattern without being told the right answer. When we are doing supervised methods, we were labeling that this crop is high yielding or low yielding. But here you don't do that. You just put in the algorithm finds the pattern without being told the right answer. Okay. So the output is now in the left, in the right. The group results are clustered by crops. So already see the healthy plants were clustered together, the stress plants were clustered together, and the disease plants were clustered together. So now the farmers can then interpret these groups, e.g., can apply fertilizers to the stressed area. You can treat the disease zone. If the farmer has maybe a bigger field, then he or she doesn't have to spray every field. Can just now go to where there's the disease zone or where there's a stress. Stress might be due to fertilizer. So the farmer, I leave this one alone here. This is healthy. But leave this one alone, doesn't do anything. This one apply fertilizer because it's stressed. And this group now treat them because they're diseased. But the information came from this here. Okay? It's unsupervised learning. Okay, deep learning. So deep learning is a branch of artificial intelligence and machine learning inspired by structure and function of human brain. I think this is what Dr. Jimmy showed us before. It uses artificial neural network with many learning layers. That's why it's called deep, to automatically learn from large complex data sets. So for example, it's used in image recognition, natural language processing, speech recognition, and autonomous vehicle. So basically what it learns by hierarchy. So each layer learns and pushes to another layer, okay? That's what it does. But the problem is requires a large amount of data, powerful computer to train effectively. So unless you have a very big investment, deep learning, unless you have a lot of money, it basically doesn't pay. But if you are like Google or Amazon, then it pays. So this is the cartoon of deep learning. We can use it, especially with crop. So you have crop monitoring system, precision agriculture, data analytics size, then you push them in all these layers. So these are the hidden layers. So this is what part of agriculture engineering comes. This is a hidden layer, okay? And then after that, it gives you the output. The input layer, this is the hidden layer, then you have the input layer, and then it gives you the output. Like these days, people are using it for automated harvesting, but the big companies are the one that are doing that, especially John Deere, they're doing that. So it's very, very powerful, but there's a lot of money because it takes a lot of computational power. So this is an infographic so the core concept, deep learning is presented as a branch of machine learning based on artificial neural network. The infographic uses multi-layer neural network diagram. So there's an input layer, there's a hidden layer, and then an output layer. So that shows how the data is processed. So how can we apply this for agriculture engineering, crop monitoring? So deep learning models analyze drone and satellite images to detect crop health, pest, and nutrient deficiencies. So these days, drone and satellite has become one of the mostly used data sets. I'll show you, I think on Wednesday, I have some data sets from drone, also have some data from satellites, how we can use that. So we're now using that, detect crop health, detect pests, and detect nutrient deficiencies, okay? And you can also use that in precision agriculture. You can use a plant and thermometric icon. So this is a neural network. It helps with irrigation, fertilizer use, or soil management based on the sensor data. So this is the concept. Okay. So the data analysis, that's the chatbot icon, is the AI process. So that's processing a very, very large amount from data. Can be weather, can be soil, can be yield record to support decision making. And then you can also have automated harvesting. So deep learning powers robots, smart machinery, and so forth. So if people talk about, you have a tractor that is just harvesting by itself, it uses deep learning algorithm. So the input flows, like agriculture data, you have images, sensors, weather, and soil. So the hidden layers now present the neural network processing. And you have the learning pattern of disease. Now you can detect. So the output is what? Classify either it is a disease or it's healthy. Can also recommend regression labels. And sometimes you have, these days you have robot. They can just be in the field. And then if everything's ready, they just start doing their own things. So because they have been trained by deep learning. Okay, I think last but not least, I'm gonna stop here for today. Reinforcement learning. So this is a type of machine where an agent learns by interacting with the environment. So these days people talk about agent. When you are trying to get some help from companies these days, you chat with agent basically. So this comes also from generative AI. So it takes action, observe the state, and receive rewards or penalty. That's what it does. So what's the goal? It maximizes cumulative reward by improving its strategy, that's policy over time. That's why you can train it with something here, then after that, it can give you something totally different. Like Dr. Jimmy said that people can now get music from even people who are dead, mix them together, and then another music will come out that's so good. So the problem, as he said, what are the ethics? So this is basically reinforcement learning. So what are you using robotics, autonomous system, agriculture, gaming, and resource optimization? So this is how it looks. in infographic. So they call it policy. So this is the agent. So it does something based on the environment. They reward it or they punish it, the agent. And then the process, it learns, keep learning, and becomes more smarter and smarter and smarter. So it took very many years for computer to beat people who were excellent chess. But because of reinforcement learning, nobody has ever beaten such computer again, because they learn from the environment and they can change. Okay, so you have, this is how they learn, by reward and punishment. And then after that, they can now be used in other area like crop management, autonomous tractor and drones, robotic, and so forth. So this is the core concept. For example, African farm environment, that's an environment. You have maize field, cassava plot, banana plantation, rangeland irrigation scheme. So the agent is agriculture equipment, drones, mobile app, acting or intelligent decision makers. So the action, decision like adjusting irrigation schedules, if they do very good job, they are rewarded. If they don't do a good job, they are punished. Deploying drones for pest monitoring or guiding tractor for planting. So reward, higher yield, reduce water use, low fertilizer costs, improve climate resistance. And the system learns the best strategy over time. How do you maximize yield with minimum resources? So what's the application? Crop management. Enforcement learning can optimize pest and disease control over crop like maize, cassava, rice, and so forth. Autonomous tractors and drones. They're becoming, especially drones are becoming now cheaper. You can use the low-cost solar power and small-scale autonomous equipment that can be adapted to small farming. Robotics, they now become also affordable. Can be using for sorting machines, post-harvest handling, and so forth. Resource optimization, managing scarce water resource in dryland, example Sahel, and so forth. So for staple food that we have maize, cassava, and sorghum. The agent tractor an agent can represent a small field. So you can use drip irrigation lines, water tank, or resource optimization. So this can be used in symbol like acacia tree, savanna landscape, and so forth. So with that, I think I'm going to stop here. So tomorrow we'll begin from here. So Jimmy, back to you. I can take question now.
Yeah, thank you, Stephen. Just to a little bit recap on what you said. At one point, we were discussing generative AI, but then later you were talking about unsupervised machine learning. I wanted to let the participants know in some circles, this unsupervised machine learning is also being referred to as agentic AI. As opposed to generative AI. And this is very, very applicable in autonomous vehicles. For instance, if I'm designing an autonomous vehicle, I'll put in obstacle sensors. You're training this machine that it can make decisions without your intervention, without you being there, because it's working by itself. So for instance, if I design a drone and it finds an obstacle, without referring to the base station, you should be able to tell that actually you can divert the course of, it can divert its course. And this is the beauty of unsupervised machine learning. I will allow colleagues to ask some questions in case you have any, as we try to prepare for also tomorrow. If you have any questions, please feel free to raise your hands. I'm glad the numbers increased to 20. That's quite good. We started, I think, when we were 13, now we are 20. So the number is increasing. Any questions?
Jimmy also asked them if they can install RA and QGIS because they're going to have some problem. Then maybe when they have the problem and they come, I will help them if they have time.
Yes, we did share with you R, the R and QGIS. Did anybody have any problem installing those two software? Because we talked about AI having use of data, so those are kind of sources where you can collect data from, but also you can use them for processing data at the same time. So is there anybody who has issues or problems in installing those two software, R and QGIS? I don't see anyone raising his hand. So I think we can say, I think for today we have reached the end. I'll hand back over to the Secretariat to close the day and give us the closing remarks for today. I thank you, Dr. Stephen, for, yeah, there's a hand. Justus, please go ahead.
Okay, thank you very much, sir. Okay, mine is a general one related to application of AI in the agriculture sector in Uganda. I wanted to find out, first of all, I want to thank you for this kind of training. I think it's relevant to our economy and their country. But I wanted to find out from your own research so far, what is the level of application of AI in the agriculture sector in Uganda? Where are we now relative to maybe some other statistics which you may be knowing? Thank you.
I don't have personally statistics, but as we said AI is an evolving area. AI at the moment is very handy as being used with irrigation equipment. For instance, when you're talking about scheduling irrigation in these large irrigation schemes like Akira, Atiak Sugar, they are using a lot of AI to schedule irrigation. It's able to help to tell how much water should be applied. For instance, you can actually now at the moment we have technology around, at least with Atiak Sugar and Akira Sugar Works, they have technology where you can tell how much water you need tomorrow to irrigate based on the cloud cover, integration of the weather patterns, and the soil moisture. They're able to tell. So it's really not something widespread because it also requires investment. Where so the smallholder farmers may still not be able, they may not have got there, but I think it's a field that is evolving and I think we're still moving. Brian, your hand's up.
Yes. Thank you so much, Doctor. I wanted to ask regarding the different types that we talked about, the supervised, the unsupervised, and the reinforcement. So of the three, which one are commonly used? I was thinking in terms of, for example, the unsupervised and supervised learning, where we look at the classification and regression for the supervised. So how often, under what scenarios do we use the unsupervised learning, especially for this in the agriculture sector? Because if, for example, one of the examples that we looked at grouping in healthy, stressed, and diseased, that can be classified and trained. So I was wondering how often the unsupervised learning is used as far as this in this specific field is concerned for in agriculture. Thank you.
Thank you, Brian. Stephen will answer this, but I can only tell you that the type of AI you need will depend on the kind of solution you want. So AI is evolving depending on different solutions you need, and two, the resources that are available to you. Like I think when Dr. Stephen was presenting, he was indicating to you that for instance, deep learning, you require a lot of computer resources. So do you have this kind of resources? But Dr. Stephen, please go ahead and try and respond to.
Let me share my screen here. Yeah, that was really a very, very good question. And one is unsupervised methods always are used for what's called exploratory data analysis. 60 to 80% of the time they use them for exploratory data analysis. And then two, if you don't have enough data for training, that's when you use exploratory data analysis. But most people use supervised. So I'm going to show you how this can help to create a supervised here. So assume we had no idea about this maze at all. Are you with me? So this is going to be part of exploratory data analysis. So after getting this now, you can turn this to supervised learning, because now you can there in the input there are segments that are responsible for this that you didn't know. In the input, there's a segment that's responsible for this, and also the same. So now you can use this to train to make it much better in the future. So most of the time, people who do AI, they use exploratory in unsupervised methods in exploratory data analysis. That's what they do. The majority after that, they go to do supervised methods. That answer your question? Hello?
Yes. It does. It does.
Thank you. Back
It's
to you,
much
Jimmy.
clearer. Thank you.
Any other questions? I think.
There's somebody put in the chat that they will need help for installing.
Okay. Yeah, I get it.
So what I will do either tomorrow or Wednesday, they will start with that to make sure that everybody has installed, everybody's going to use it. Okay?
But maybe let us hear from him. Just request to be more audible. Thanks. Interesting looking. The question. Thanks. We will need guidance on installing the two softwares. Did you try to install before you even ask for guidance? Because we would want to see that I try to install, and then that is engineer Gordon. Did you get any errors? Were able to download the software, for instance, and got some errors? He has not got the link. So I think that's now something else, because then the secretariat should be able to handle this. Mr. Letts, please share. I know he had shared, but probably maybe it could have maybe shared a little bit earlier than he joined. So I think let us first get the link. Let you first get the link, download, and try to install, because it's actually direct, is straightforward. There's not much unless you get errors as you're installing. The only way you can get errors, maybe unless your computer resources are low, but we should be able to have no problem. So let me hand back to Secretariat and maybe try and see how we can help our participants to get these links so that they download and install before we start actually using these two softwares. Back to you, Secretariat. Thank you.
Thank you, Doctor, and thank you all the participants. Yes, it has been a day of start. We could be having issues in and there, but we have stabilized. We expect another number to increase. More people will increase. And we are going to share all the training presentations. And also the program I shared earlier. You'll also receive the link for the software on your emails for those one who have attended all today. And then, as I said earlier, the certificate for this training will be issued next week at Munyonyo. If you are not attending the conference, probably we shall come back with the certificate and you get it from the secretariat. For those who don't know our system that we issue online, but for this one specifically, since it is a special case, we are going to have hard copies. I thank so much. I invite Engineer Julius Caesar to come and close us for today. And maybe if there is anything you want to add, then we close. Thank you.
Thank you, our facilitators, Dr. Opio, Stephen, and Dr. Jime Biakatonda. Myself, I've also had very good insights in AI. And for our participants, we are going to adopt more CPDs related to AI because AI is a new kid on the block and is here to stay. And we're also working with STI. Actually, for purposes of this training, we were supposed to have today in a practical environment, but resources limited us. We couldn't raise the participation fees, but we anticipated to get a support, which has not come in time. If and when this support comes, we shall call upon you. And also going forward, maybe in the next steps, we shall call you again and we have it in a practical environment. Facilitators and members on call have got already the environment, but there are resources required to make it for our participants. We would have had a virtual, but we are still hopeful and we are happy for today for those who have joined us. We know the times are economically demanding and knowledge and growth is part of our life as professionals, so we cannot hide away from it. We shall move under all circumstances. Thank you for today, and let us keep time tomorrow. Tell a friend that the training is on and the conference is on next week. I thank you, facilitators, and we meet tomorrow.
Okay, thank you. Bye-bye.
Thank you.
Bye-bye.
Bye.
Thank you.
Thank you.
Bye.
Bye.